This is the video for lesson 6.1. At the top of your page, please write down the learning target. I can use proportions to identify similar polygons. Similar polygons are slightly different than congruent polygons, of course, because congruent polygons, which is what we've been talking about in class, are exactly the same size and shape. But as you're going to learn in this video, proportional or similar polygons only have the same shape. They're going to be slightly different in size. So if we want to begin here, let's begin with the vocabulary. Two polygons are similar polygons if corresponding angles are congruent. So the angles themselves have to be congruent, and the corresponding side lengths are proportional. Proportional means that they have a different length, but they have the same scale factor, and we're going to talk about that in just a moment. If two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. And another word for ratio is fraction. So if we're looking at the ratio, we're looking at the fraction of smallest side to biggest side, and they would have to be the same on all of the corresponding sides. Now we have Theorem 6.1, perimeters of similar polygons. So just a reminder, perimeters are the measurement of all of the sides added together. So it's the distance around a polygon. If two polygons are similar, then the ratio of their perimeters, the distance around them, is equal to the ratios of their corresponding side lengths. So just a reminder, as I stated previously, a ratio is a fraction. So when we look at ratios, we're just looking at a number over another number. We'll have some practice at that in this lesson. Corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. So these are things that we need to understand in order to proceed with the lesson. One last thing I would like you to include here is the properties, the three properties of similar polygons. This will come up on a quiz question, maybe a warm-up question, those kind of things. So please write these things down. Properties of similar polygons. First of all, polygons that are similar have the same number of sides. A triangle cannot be similar to a quadrilateral. Okay, so they have to have the same number of sides. They also have to have congruent angles. So the angles themselves are the exact same measure. The third and last property is what we just stated, is that the side lengths, the lengths of the sides, are proportional. Proportional means they have a similar size, but they are scaled up or scaled down, but they're all scaled in the same amount. Okay, the measure of the scaling is the same on all of the sides. We're going to take a look at example 1. Example 1 asks us to find the scale factors. So we need to determine whether these two polygons over here are similar. And if they are, we're going to write a similarity statement, and we're going to find the scale factor of this polygon here to this polygon here. So if you look at the side lengths, you can see that this polygon DEFG is smaller than JKLM. So we need to set these up in a fraction. So over here to the side, I'm going to set 15 over 20, and then I'm going to reduce that. 5 goes into both of them. So if I reduce it, then that means my scale factor for just those two sides is 3/4. And I need to do that for all of the corresponding sides. So corresponding means that they're in the same position, and if I look carefully, I see that EF has a 6 and KL has an 8. So let's see, 6 over 8, and if I reduce that, again, 2 goes into both of them, and 3/4 is my scale factor. So far, I have two side lengths that have the same scale factor, and I need to verify that all of the sides have the same scale factor, and if they do, then I have polygons that are similar. 12 and 16 are corresponding side lengths, and so I'm going to reduce this. The number 4 goes into 12, and the number 4 goes into 16 to reduce to 3/4. So now I have three sides that are similar because they have the same scale factor. And then I need to look at the last two sides, 9 over 12. 3 goes into each of these numbers, and so there I see that the scale factor is 3/4. Remember, you want to reduce your fractions, so taking the numbers of the side lengths and putting them over each other and then reducing it, that's going to become our scale factor. The similarity statement basically reads these two polygons, and these are quadrilaterals, are similar if you write it like this. So DEFG is similar, that's just our little squiggle sign, JKLM. So before we were writing congruent, but now we're writing similar, and this is the symbol for similar. We don't have to write the congruent sign because remember, these two polygons are not the exact same, but they're similar. They have a similar shape, but the size is definitely different. So yes, they are similar. We couldn't say initially that they were until we verified that they have the same exact scale factor on all of the corresponding sides. All right, for example number 2, we want to use similar polygons. So we already know that these polygons are similar as it states right here. So it says triangle ABC is similar to triangle PQR, and we need to find the value of x. So they've already indicated that these two triangles are similar, and so we can use the two sides that are corresponding to find out what the scale factor is. So if I have a 6 and a 9, I'm going to reduce that. 3 goes into both of these numbers. So my scale factor is going to be 2/3. That's one thing that I have to do first. This is step 1. Identify what the scale factor is. And now, because I have an x and I want to find out what this length is, I'm going to set up a proportion, and you may remember this from math quite a while ago. A proportion is two fractions set equal to each other, but one part of the fraction is missing. Okay, so I don't know what the length of PQ is. I do know that its corresponding side is 14 in the smaller triangle. So the one thing that I really want you to think about is that this number came from the small triangle, this number came from the large triangle. So when you set up your proportion, make sure that you set the small number, the number that came from the small triangle, on the same part of the proportion as you do for the scale factor. Okay, now what we're going to do is we're going to cross multiply. So we're going to take 3 times 14 and set that equal to 2 times x. 3 times 14 is 42, and we set that equal to 2x. We're going to divide by 2, so x is going to equal 21. Using the work that you did in examples 1 and 2, please finish the practice or on your own problems at the bottom of the front side of your note sheet. In example 3, we need to find the perimeters of similar figures. So the perimeter, remember, is the distance around, outside. So if we add up all of the outside lengths, we should find the perimeter. Now, we have all of the lengths on the larger quadrilateral here, but we don't have the lengths of this side, and this side of the smaller quadrilateral. But if we take a look at the names of the quadrilaterals, we'll see which sides are corresponding. So if we want to know what the length of HJ is, we would have to find the scale factor and then look and see how long CD is to find that length. The difference here is going to be, we're going to find the scale factor of the two different quadrilaterals, and then we're going to use the perimeter of the large quadrilateral to find the perimeter of the small quadrilateral. So first of all, let's add up these 4 side lengths. 8 plus 10 plus 12 plus 15 is 45. So I know the distance around ABCD is 45. And I'm going to use that down here in just a moment. But I do need to find the scale factor of this side, JF, to the side that it is corresponding to, which is going to be this side, AD. All right, now how did I know that? Well, In the names of the quadrilaterals, A is first, D is last, and that matches up with F being first and J being last. So remember, if the shape doesn't look like it's the same exact shape, check to see if one of them is upside down. Notice that this whole quadrilateral is turned a completely different direction. So I'm going to line up 8 to 12, right? This side, JF is 8, this side, AD is 12. And if I reduce that, I'm going to get 2/3. So my scale factor is 2/3, and I'm going to set that equal to the perimeter that was the perimeter of the larger quadrilateral. I don't know what the perimeter of the small quadrilateral is, but as we did in the previous problem, remember this was from the large, this is from the small, this number is from the large quadrilateral, and we're trying to find the perimeter of the small quadrilateral. So make sure that you set up your proportions so that you have the small numbers on top, the large numbers on the bottom. All right, and then we are going to cross multiply. So we can cross multiply here. 2 times 45 equals 90, and 3 times x is just 3x. So 90 equals 3x. If I divide by 3, x is 30. So the perimeter of the small quadrilateral has to be 30 because the scale factor is 2/3 and the perimeter of the larger quadrilateral was 45. So as you can see, scale factor is a very important idea when we're dealing with similar polygons. It just basically tells us how much smaller or larger one polygon is versus the other. So let's take a look at this last example, and then you're going to have some on your own problems to solve. Using a scale factor, we need to find the length of the altitude, xz. So we need to find this altitude. An altitude is a distance from a point on the triangle directly straight down, so perpendicular to the other side. Now we know the altitude of this triangle, which is 18, and it does tell us here that these two triangles are similar. Notice the symbol here says that they are similar. So if they are, we can take the sides that we see on each one here. We have a 25 and a 30, and we can calculate the scale factor because the altitude xy is going to be similarly proportioned to the side length of 18. So what is the scale factor? Well, 5 goes into both of these numbers, so the scale factor is 5/6, and now I can use my scale factor 5/6 to create a new proportion. I don't know what the altitude is on the smaller triangle, but I do know what the altitude is on the larger triangle. So anytime you're trying to find a missing part, you can use cross multiplication inside your proportion there. So 6 times x is just 6x, and 5 times 8 is 90. So if I divide by 6, I see that the length of xz is going to be 15. Now I can check that. So in order to check it out, I would take 15, which is the smaller altitude, and put that over 18, and if it reduces to the same exact scale factor, then I know I'm correct. I know that 3 goes into both of these, and I can see that I'm correct. So that's just a good idea if you're taking a quiz or a test. You want to check your answer to make sure that you're not, putting down an incorrect answer. So there's a way to check it. So in this last practice problem, it's telling you that these two pentagons, notice that they have 5 sides, are similar. Okay, so you want to find the scale factor first, and you can do that by looking at the sides that are corresponding and reducing that fraction. And then I also need you to find the perimeter of the second pentagon. We could find the first pentagon perimeter by looking and adding up all of the side lengths that you see there. And then we also need to find the length of the diagonal. A diagonal connects two vertices, so we're looking for the length of OM as well. So once you find the scale factor, That's going to help you find the perimeter and find the length of that diagonal, because you can see the length of the larger pentagon's diagonal is 25. Try these problems out on your own. Remember, you can always rewind the video and watch the parts that you didn't understand the first time. And then, of course, I'll answer some questions in class. Thanks for watching.